This is video 2 for logarithms, so let's learn more about logarithms here. We did a very brief intro. We learned how to convert and how to mentally evaluate, but there's so much more to logarithms to learn. So I realized we can mentally evaluate. We did that in the last video. So log base 3 of 27, I'm thinking, all right, what exponent of 3 will give me 27? And it's 3. However, not every logarithm question will be set up nice like this and give us whole numbers, because not every number in real life is a whole number. So what if I had log base 3 of 24? I really have no idea what exact exponent of 3 gives me 24. I mean, I know it's going to be close to 3, a little bit less than 3, but I have no idea. So in order to tackle this problem, we need to first realize that there are two types of logarithms out there. The first type is a common logarithm. Now, the reason they call it common logarithm is because it's so commonly used. And a common logarithm, these are things you need to remember. Common logarithm has a base 10. So we know that every logarithm has a base. This one happened to be base 3. A common logarithm has a base 10, and it is the most common type of logarithm used in natural real-world modeling. And it's so commonly used, in fact, that if you needed a base 10, you don't even have to write it. Like, this is how you write it, log of 10. You often write it with no base. Actually, you always write it with no base. If there's not a base there, you need to assume that it's base 10. And on your calculator, let's jump over here, whoop, that is what this key is for. So if you type in 10 and you say, hey calculator, tell me what log of 97 is, your calculator is telling you what log base 10 of 97 is. Even though you didn't type in base 10, this button means common log base 10. All right, well, there's another type of special logarithm, and it's another very commonly used one, and it's used in a lot of real-world modeling, and it's a natural choice, so they call it the natural logarithm. These two make up like 99% of real-world modeling problems. This one has a base e, and we talked about what e was. Remember, e is on our calculator. There it is, 2.718 ... It's an irrational number. It's, again, very commonly used, so commonly used, in fact, that you don't write base e there. This is another one where you can completely omit the base, no base. But this time, if there's no base and we use the letters ln, you need to know that it means natural logarithm. And for that, you hit the ln key. So if you say, calculator, what's natural log of 97? It's obviously different than log of 97 because this was base 10. This was base e. So natural log is ln, it's base e. Common log is just log, base 10. Neither of the two have an actual base written down. Okay, so now that we know that, we can go back to tackling this problem here. I still don't know what log base 3 of 24 is. Well, you can't just go on your calculator and do log of 24, log of 24, or natural log of 24, because the first one was base 10, the second one is base e. I want base 3. So what you need here is what's called a change of base. This is, again, something you need to know how to do. Change of base is whenever you want to be able to evaluate something on a calculator, but it has a base that your calculator doesn't know. So here's the deal. If you need to do it on the calculator, you need to rewrite this logarithm. And you need to rewrite it using a quotient, so division, of two different logarithms. And you can either do it with the common log, so common log of 24 over common log of 3, or you can do it with natural log of 24 over natural log of 3. And the way you remember it is that the base goes on the bottom, and the number here goes on top. Or as Kenneth liked to say, he's famous for coining this phrase here, you drop the base. So the base goes on the bottom, you drop it down here. Actually, the change of base formula is really written as log base a of this number divided by log base a of the base. So really, you could write it as the quotient of any two logarithms with the same base, but it just wouldn't make sense to do it with anything other than 10 or e. Because, yeah, this is the same thing as this, but writing it like this doesn't do me any good because I still can't do either of these on my calculator. So it's only advantageous if you write it as a common log or a natural log, because now I can do it on my calculator. So what I would do is log of 24 divided by log of 3. And notice that's different than either of these two. It's actually in between it. Or you could do natural log of 24. Try this on your calculator. Watching me, you're missing out on the fun here. And doing the keystrokes will cement it in your mind more. So it's the same thing whether you do log or ln. So what was that number again? 2 point something. 2.893. Let me just put that here. So you can add that to your notes so you remember what we got. 2.893. Okay, moving on. What I want you to do now is write this list down, and I want you to find / evaluate each. Evaluate just means find what it is. You're going to use your calculator for all of them. Some of them need change of base, some of them don't. You decide. Remember, you only need change of base if it's not a base 10 or a base E. If it's base 10, like this guy, or base E, like this guy, you don't need change of base. Just literally type it right in your calculator. Why don't we decide on 3 decimal places? So pause the video and write those down. In class, we'll go over this. So I'm not going to put the answers up right now, but make sure you've paused the video. And I'm going to go on to slide 2. Okay, so before I move, again, make sure you have paused the video and you've written this down, and make sure you've actually done this on your calculator before moving on, because we're going to learn one more skill in the video. Let's do a few basic solving. We're going to do like 1 step and then maybe 2 or 3 steps, nothing more than that. We'll practice in class maybe Friday with the whiteboards. So let's go back to the very first question I had in video number 1, which is 3 to what power is 40? So I still haven't found that. Let's do it right now. What I'm going to have you do to solve, I'm going to show you 2 to 3 different ways to solve exponential and logarithmic equations. The first method that I'm going to show you, so first method, or you can call it method number 1, whatever you want, is with converting. And make sure you remember how to convert. It was if x equals b to the y, then y equals log base b of x. So I can't really go anywhere with an exponent of x. If my variable is stuck in the exponent, I need to get it out of the exponent. That's really the only way to do much of anything, unless I want to sit here and do guess and check for 5 minutes on my calculator and try to get close, which I don't want to do. So we're going to convert to logarithmic form. So we need to go to log form. So x equals b to the y equals log base b of x. Well, this calls for the change of base if I actually want to find out what this is. I tend to do common log more than natural log. That's like my first instinct here. So do that on your calculator, log of 40 divided by log of 3. And you should be getting 3.358. Let me do one more with you here, and then I'll give you a list to do. These are really quick. These are like the baby ones. They don't really get much easier than this. 5 to the x equals 20. So I want to know what power of 5 gives me 20. It'll be close to 2 because 5 squared is 25. So I have x equals b to the y. So let's convert it. Y equals log base b of x. Again, I need some change of base action here because it's not a common log or natural log. And again, if you go on your calculator, log of 20 over log of 5. I didn't do the other one on the calculator, but you should have a calculator in front of you to do the rest that I'm going to give you. 1.86. So yeah, it's close to 2, a little bit less. So again, all you're doing is converting to logarithmic form using change of base to get it as a decimal answer. So why don't you go ahead and do these 5. Nothing too crazy here. They're all 1 step. Pause the video and do these now. So you should be back. You should have tried all these on your own. And hopefully you got these 5 answers. Notice this one was the common log. So you should have only had to just use the LOG button on your calculator. And this one was the natural log. You should have only had to use the LN button on your calculator. So make sure, again, you have these. You need to have the filled in work where you're converting like this and where you're doing change of base like this. Okay, so if you didn't get one of those, try again. Make sure you get those right. Now these are going to get boring if we keep sticking with ones like this. These are the baby ones. We want to get to the more interesting ones. Let's do 2 and 3 steps on the video, and then in class we'll work together on the more challenging and involved ones. So all that we're really going to add is some adding, subtracting, multiplying, and dividing at the end. So your goal here is always get the exponential term alone before you do anything else. So I can't convert yet because this isn't alone. So this needs to be completely alone. So what I'm going to do is let's add 3 to each side. And then I have e to the 2x equals 47. And then, okay, x equals b to the y. Y equals log base b. Oh, log base e is ln. Log base b of 47. So let me go on my calculator and get ln of 47. 3.85-ish. But you know what? I want a perfect answer. I don't want a rounded answer. So let's just keep it like that for now, because I don't want to round 2 times. I'll only round once at the end. So to get x alone, I'm going to be dividing by 2. So check this out. I'm just going to say divided by 2. Notice it is not the same as this. These are 2 very, very different things. So I don't get the same thing. That was bad. The one I did before was good. 1.925. 1.925. There we go. Let me do one more with you quick. So you have to decide what is the base of the exponent. The base is 9. The base is not 10. 10's just there. It's an extra number. We don't want it, so we have to get rid of it. So divide by 10 quick. Boop. And I now have 9 of 3x equals 50. And I have x equals b to the y. Let's convert to logarithmic form. X is b to y, y equals log base b of x. Again, this converting is just one way of solving this. I will show you another way. And I'm going to need to do some change of base to get this. Log base 50 over, log base 10 of 50 over log base 10 of 9. And then what I'll need to do is divide that answer by 3. So I have x equals this. So I have log of 50 divided by log of 9. Okay, log of 50 divided by, some people really like writing the decimals every step. I kind of prefer to get the decimals on the calculator and only round 1 time. So let's divide by 3. So answer divided by 3, and I have 0.593. 0.593. Bam! There we go. So that's all. So what I'm going to have you do is this set. These are the exact same type as these. Remember, always get your exponential term alone. In this case, the exponential term already is alone. It's just after you convert, you'll have to deal with the 3 up here and with the 2 up here. Again, my exponential term's alone, but you'll have to deal with the 7 at the end. Here is my exponential term for these guys. So try those. And we're going to go over the full solutions in class. And if you come to me before the homework's due, I can definitely show you the answers if you want some feedback to see how you did. Homework assignment number 2 that goes with this one is on page 520, and it's 12 through 20 all. And as always, we're showing our work if we want credit on our homework. Okay, cool. I will see you Thursday after MCAS.